multi-protocol label switching. See, in our network, packets are usually switched using MAC address. Okay, it is the MAC address that moves the packet from one routing device to another routing device. But here we are going to use label. Yeah, we are going to use label. What may be the reason? What is wrong with MAC address? See, we still use MAC address. I'm not going to replace MAC address. Still, the MAC address is going to be used for switching. But along with MAC address, I'm adding label also. Then why I'm doing this complicated thing? I already have IP address, port number, MAC address. If I'm going to use label for switching, then I should not use MAC address. When I'm using MAC address, also the label. Oh, what is the use of this? We are already switching using MAC address. Why do I need another label for switching is what the question is. This answer to the question is what the whole story of MPL is. If someone will answer this question which I just asked, only then they know MPLS. If you know just to enable MPLS and then do some MPLS based traffic forwarding, that is not really knowing MPLS. If someone can answer this question which I'm asking now, if someone can clearly explain, then they know MPLS. I'm not actually expecting answer from you right now, but if someone is trying to give an answer, you are most welcome, because I heard someone turning on the mic. You want someone to, anyone who wants to answer this question? Go ahead. Okay. I appreciate that answer, but I want more detail. Yes. Yes, ma'am. You also want to say something? See, this answer is 10%, 100% correct, but I really want to know, you know, the depthness of the answer, the meaning in depth. Can you make it more elaborate? Please listen to the words that she used. I'll repeat what she said and then she will add something more to it. இருங்க ஐயா ஐயா இருங்க ஐயா அவங்க சொன்னதை நான் ஒரு முறை சொல்லிடுறேன், அதுக்கப்புறம் அவங்க இன்னும் கொஞ்சம் எக்ஸ்ப்ளனேஷன் அவங்க கொடுக்கணும்னு நான் எதிர்பார்க்குறேன். அப்போ தான் அவங்க எவ்வளோ ஆழமாக தெரிஞ்சிட்டு இருக்காங்கன்னு எனக்கு தெரியும். அதுக்கப்புறம் நீங்கள் சொல்லுங்கள். இப்போ என்ன சொல்ல வராங்கன்னா, அவங்க இன்ஸ்டெட் ஆஃப் ப்ராசஸிங் த பேக்கெட் அப்படிங்கிற ஒரு வேர்டை வந்து கொட்டேஷனுக்குள்ளே போட்டுடுறாங்களா, அதனால நான் கன்ஃபியூஸ் ஆகிருக்கிறேன் இப்போது. ஸோ பேக்கெட் ஒவ்வொரு ரவுட்டர்லேயும் ப்ராசஸ் ஆகிறதுக்கு பதிலாக இன்க்ரீஸ் ரவுட்டர்லேயும் ஈக்ரீஸ் ரவுட்டர்லேயும் மட்டும்தான் ப்ராசஸ் ஆகும் எம்பிஎல்எஸ் எனேபிள் பண்ணிட்டோம்னா. மற்ற மிடில் ரவுட்டர்ஸ்லாம் just by popping the label and pushing the label and pushing the label and swapping the label, the packets can move from one PE to another PE. The packet gets processed only on increase PE and egress PEங்கிறாங்க. அது 100% சரியான ஆன்சர். இட்ஸ் 100% ரைட் ஆன்சர். பட் I want more explanation to it. Yes, ma'am. You want to give a try? இல்லை அதில் வந்து ஆன்சர் மறைஞ்சி கிடக்குது, எக்ஸ்பிளிசிட்டாக இல்லை. இப்போ அங்கே தான் நானும் இப்போ ஸ்ட்ரக்காக நிற்கிறேன். அவங்க பேக்கெட்டுங்கிற வார்த்தையை வந்து யூஸ் பண்ணிட்டாங்க. யூஸ் பண்ணதுனால அந்த அட்ரஸ், அந்த ஆன்சரே வந்து 100% சூப்பராகிடுச்சு, அக்யூரேட் ஆன்சர் ஆகிடுச்சு. அப்போ நான் கேட்குறது என்னென்னா, ஃபஸ்ட் ரவுட்டர்லேயும் லாஸ்ட் ரவுட்டர்லேயும் மட்டும் தான் பேக்கெட் ப்ராசஸ் ஆகுமா, நடுவில் இருக்கிற ரவுட்டர்லாம் பேக்கெட்டே இருக்காதா, ப்ராசஸும் ஆகாதா? அதுதான் என்னுடைய கேள்வி. இப்போ அதுதான் அவங்க இன்னும் கொஞ்சம் சொல்லுவாங்கன்னு பார்க்குறேன் நான். சரி, நம்ம ரமேஷ் சார் இதை சொல்ல விரும்புகிறார், அவர் சொல்லட்டும். சொல்லுங்கள் சார். பாப்போம். Okay, label. Okay, router by router label processing will make the packet forwarding faster, and Mr. Ramesh is trying to explain us. Fine. You see, in networking, packet, the word packet means two different things. That is where I am struck. இவங்க எந்த பேக்கெட்டை சொன்னாங்க அப்படிங்கிறதுல நான் மாட்டின்னு முடிச்சுன்னு இருக்கிறேன். இன் ஜென்ரல், ஐயா அவங்க தானே ஐயா சொன்னாங்க, அவங்க தான் பதில் சொல்லணும், நீங்கள் சொல்லின்னு இருக்கிறீங்க. வெயிட் பண்ணுங்கள், அவங்க சொல்கிறீங்களா, நான் ட்ரை பண்ணி வாங்கிக்கிறேன். ஸோ நீங்கள் 19 பிஹெச்பி கூட பேக்கெட்னு யூஸ் பண்ணிட்டீங்க. உங்களுக்கு என்னன்றது எனக்கு புரிஞ்சிடுச்சு, உங்கள் பேக்கெட் மீனிங் என்னன்றது எனக்கு புரிஞ்சிடுச்சு. அவங்க பேக்கெட் மீனிங் தான் இப்போ எனக்கு புரியாமல் அப்படி ஸ்ட்ரக்காக நிற்கிறாங்க. இதை தான் சொன்னாங்களா? ஐ வாண்ட் டு கன்ஃபார்ம். என்ன அன்பு, நாங்கள் சரி. அன்பு சார் இருக்கிறீங்களா? நாங்கள் பேசுகிறதெல்லாம் உங்களுக்கு போர் அடிக்கக்கூடாது, ஒரு புரிதலை உண்டாக்கணும். அதனால தான் நாங்கள் பாட்டு பேசின்னு இருக்கிறோம், உங்களை கண்டுக்காமல். நாங்கள் உங்களை கண்டுக்கலன்னு மட்டும் நினச்சிக்காதீங்க. இந்த கிளாஸில் பாயிண்ட் ஆஃப் அட்ராக்ஷனே நீங்கள் தான், அது மந்திராதீங்க. ஓகே, ஸோ யூ see here this next page. Here when they say IP packet, what does that mean is, the data is moved from one hop to another hop based on the IP address. Here it is not talking, when most of the people say packet, it means data. Most of the time when people say packet, it means it doesn't mean layer 3. Most of the time when people say packet, it means data is going. Packet is coming means what? Data is coming. But when we talk about MPLS, we need to be very precise, because MPLS deals with layer 3 address and label. So I want to know which packet. Now, an IP packet is coming, which means there is no label, which means the routers before this router, they only read the incoming packets destination IP address to decide the exit port. The exit port is decided based on the destination IP address. That is what here it means when it says IP packet. But you all know, we are all very good in CCNA. we all know that even though it is destination IP address, the routing table, when it says go this way, this interface MAC address and this interface MAC address becomes the source and destination using which the packet is switched from here to here. MAC address is there always to switch. Layer 2 switching we call it as. But in MPLS what it says, label switching. Is this label switching replaces this layer 2 MPLS, layer 2 MAC address switching? No. It's not replacing. Then what is the role of this one? The role of this one is, you already know it. Everyone answered that part of the question. What you said, when this router wants to determine the exit interface, it finds the exit interface has got MPLS enabled. So it is doing packet processing, as our ma'am said. When I say packet processing, what does that mean? It does layer 3 processing. Layer 3 processing. But when it was about to send the packet out on that interface based on the routing table, safe table says, wait, there is a label on that path. Use the label. Then what it does, it pushes the label and send the packet to the next router. Now next router, what it does is, it receives the packet, layer 2 MAC address is matching. Now when it was about to go to layer 3, there is another layer sitting in between. Usually layer 3 will be there. Packet comes, layer 2 MAC address is matching here. So layer 2 processing is done. When it was about to read the layer 3 header of the incoming packet to know to which network this packet need to be forwarded, it couldn't see layer 3. Instead it see another layer. You can call it as 2.5 layer, which means layer 3 is not there right after layer 2. This is what MPLS layer. MPLS label is sitting there. Now when it reads the label, it knows the exit interface. Whereas in this router, to know the exit interface, there was no label given by the before router. It learned the exit interface after reading the destination IP. Whereas here on this router, to know the exit interface, that label which was found in 2.5 layer itself is sufficient enough. Okay. What is the advantage? Advantage is this MPLS layer is only 32-bit. Just by reading this 32-bit header, router is able to decide on the exit port. Whereas this router, to decide on the exit port, it needs to read the entire layer 3 header, which is some thousands of bits. Thousands of bits. To know the exit interface, to know which direction to send, to know the destination where the packet need to be forwarded, when it is only IP packet processing, it needs to read thousands of bits optional bit, TOS bit, TTL bit, protocol bit, fragment bit, source and destination IP bits, and much more. Whereas this router, which is fully immersed into label on both the side, decided the exit interface just by reading 32 bit only, not thousands of bit. This makes the communication faster. Adan number Ramesh avargal sonnaanga. That makes our communication faster. And now this router, what it does, after knowing the exit interface, when it tries to send, Ceph says, Okka nimisha, wait Madi, just wait for a minute. There is another label you need to swap. Okay, I'll swap with that label and send the packet to next router. Next router again, after receiving, it checks layer 1, layer 2, and when it is about to read layer 3, there is another 2.5 layer. It reads the label, it determines the exit interface. Now, in less time, it was able to move the packet to the next route. And let's say this is the last router. As our Ramesh ji said, this will be popped off. Only IP packet will go. That's called PUHP. Don't worry about that. I'm going to teach later. Now this router will do what? IP lookup. That is what I was asking madam. Madam was saying IP processing means IP packet processing happens only on the ingress and on the egress. There is no IP processing. அந்த மீனிங் தான் அவங்க சொல்லியிருப்பாங்கன்னா அவங்க ரொம்ப ஆழமாக தெரிஞ்சுட்டு இருக்கிறாங்கன்னு அர்த்தம். இல்லை பொதுவாக பேக்கெட்டுன்னு நான் சொன்னேன் அப்படின்னாங்கன்னா அது கொஞ்சம் இன்கம்ப்ளீட் ஆன்சர்னு அர்த்தம். That is what I was trying to understand. Okay. Please ask me question. You see, OSI is 7 layers. Right from application down to physical. We have 7 layers. 7 layers. Now, MPLS, when you enable, what happens? Right after this data link layer, the MPLS will sit here in between. For that, you need to give some number, no? See, OSI is a standard. You cannot make this as layer 3, MPLS layer as layer 3, and this as layer 8. சொல்லும் போதே கொஞ்சம் கஷ்டமாக இருக்குல்ல. ஓஎஸ்ஐனாலே 7 லேயர் தான். ஏன்னடா இது ஸ்டாண்டர்டே பிரேக் பண்ணுது, லேயர் 8ன்னு சொன்னால் நல்லா வருது, கேட்கறதுக்கு ஒரு மாதிரி இருக்குது. ஓஎஸ்ஐ லேயர் இஸ் ஆல்வேஸ் 7 லேயர் ஒன்லி. அப்போ என்னடா பண்ணுறதுன்னு யோசித்தாங்க. யோசிக்கும்போது நொடி பொழுதில் வந்தது தான் இது. என்னது ஐடியா, நாம் ஏன் 2.5ன்னு இதை கூப்பிடக்கூடாது? நெட்வொர்க் லேயர் 3 தான் சொல்லணும், அதை மாற்ற முடியாது. டேட்டா லிங்க் லேயர் we cannot call it as any other layer, it should be layer 2 only. This cannot be changed, it is a standard. Then what name to give? Let us say 2.5. MPLS layer got a number in OSI called 2.5 layer. What that? We need to know some terminologies. Almost all routers, support MPLS in Cisco. That feature is on by default. You no need to turn. You need to put some command to turn on, but it's ready to use. That's what I want to say. You no need to install some extra package. Not every vendor will do that. some vendor you need to install some extra package. Even in Nexus, if you want MPLS, you need to buy additional license. MPLS will be there, but it will be in a disabled state. It won't get enabled at all unless you buy the license and put the license. After that, you enable the feature, it will get enabled. But on the routers, on all devices, MPLS is supported by default. Yeah. Now, those routers that supports MPLS are called as LSR routers, label switch routers. Wherever you can enable MPLS, and from there onward, from that moment onwards, packets are forwarded based on labels. All those routers that can move the packet only based on labels, they're all LSR routers. By looking into the label, they know the direction and they forward. So in that case, this edge router cannot be called as LSR. This edge also cannot be called as LSR. This middle router is only, swap the label and push the packets. These are all LSR routers. See, the router that make up the provider's core network and make the forwarding decision on MPLS label. Now, this router is called as LSE or LER, label edge router. Label edge router. This will do either insertion of label or adding of label or popping of label, disposing of label, impose or dispose, add or remove. No swapping. See, IP packet is coming. This guy inserts a label and send the packet. This guy R1 did not take decision based on label. It just added a label and pushed it. This is the router which is going to decide the routing based on label. That decision making is what called as label switching. Instead of looking into the layer 3 header, which is routing, you are just looking into label to move the packet. No, so they don't want to use the word routing. Layer 3 only routing starts. So they want to name this as label switching only. Because it is not above layer 3. It is label. Label is below layer 3. Anything below layer 3 cannot be called as routing, no? It's 2.5 also. 2 is switching, so this is also switching. Label switching. So, label edge router, the router that provides the customer facing interface. This is customer facing. This is edge router, provider edge router. And this is what going to add label. And this is the other edge of the provider, and this is the customer. This is where the packets are sent as an IP packet, no label, nothing. Customer has got no clue that you used MPLS. Sender also don't have a clue. Receiver also don't have a clue. So these edge routers send only the IP packet and receive only the IP packet. They pop the label and they add the label. Such routers are called as label edge router. Now what is LDP? In Cisco, when you enable MPLS, the protocol called LDP gets enabled. According to Cisco, both looks same. MPLS and the LDP, both are same, according to Cisco. But in other vendors I have seen, you need to enable MPLS. After that, you need to enable LDP. Because in reality, LDP is not MPLS. LDP is different protocol. Yeah, LDP is different protocol. The job of LDP is to send the labels to other routers as an update. See, that's what here it is written. A protocol called LDP is used by MPLS participating router in order to exchange the MPLS label information. So using that label, only what the other router do, they decide the exit interface. In another word, they decide the next hop for the labeled traffic. So what is the purpose of LDP? It is to distribute the label. It is to advertise the label. It is to exchange the label. Using the labels, only packets are moved towards a gateway, towards the destination, towards a direction. In another word, you can call it as next hop. Only based on the label, which next hop to be sent is determined. Okay. So, three terms: LSR, LSE is also another name given to this. Label, switch, edge. LSE, LSR. LDP is one protocol. There is also another protocol by Cisco called TDP. Tag distribution protocol. Tag distribution protocol. Tag distribution protocol. LDP, label distribution protocol. In Cisco, when you enable MPLS, this gets enabled automatically. Even though it's a Cisco protocol TDP, it is not getting enabled when you enable MPLS. If you want, you have to enable it separately. But LDP, you don't need to enable. When you enable MPLS, LDP gets enabled. The name difference: tag distribution protocol. This is label distribution protocol. The other difference is the port number. TDP uses 711. LDP uses 646. Both will initially use UDP, then they will switch to TCP. Initially, before discovering the neighbor, this is UDP. After discovering the neighbor, it is TDP. What am I saying? TCP. TCP is after discovering neighbor. Yes, MPLS discovers neighbor, LDP neighbor or TDP neighbor. First they discover neighbor. To discover the neighbor, because they do not know the neighbor, they have to do multicasting. They have to send hello packets. Yes, MPLS also, like routing protocol, sends the hello packet. And that time, this LDP and TDP will be using UDP because UDP is connectionless. All right, fine. Now, where is MPLS used? That was a Ramesh question. What scenario we can go for MPLS? See, I have seen MPLS even used in customers' autonomous system. Mostly people will say MPLS is in service provider side. That is true. But who stops you enabling MPLS within an organization? Nothing wrong. So not only service provider runs MPLS in their core, I have seen customers inside their organization to make the routing decision faster. They enable MPLS. If their all devices supports MPLS, then they can go for MPLS. Nothing wrong in doing that. So who are all using MPLS? Enterprises, service provider. Even in some part of data center, I have seen MPLS. When they do inter-data center communication, I have seen MPLS VPN there. All right, so Internet versus MPLS. Internet versus MPLS, what does that mean here? Moving the packet from one region to another region only based on IP and IP supported VPNs like IPsec. This is internet. IP based routing. Based on the destination IP, the packets are forwarded to the gateway. No labels involved. And then in order to protect the data that goes via internet, we use IPsec VPN. That is internet. No labels involved. Only IP and IP based feature. That is internet. Moving from one site to another site purely based on the destination IP address, whether it is with VPN, security VPN, or without security, it doesn't matter. That is internet. MPLS is, as we just saw in the previous slide, this slide, customer is sending the packet as an IP packet. The edge routers they inject the label here. The edge router injects the label. Using the label, all the LSR routers move the packet to the other edge, other end. Purely based on label. Now, if you ask, is this secured? Of course it is secured if you would have enabled IPsec like here. If you would have enabled IPsec, this would have sent an encrypted packet only. with the destination IP. To that destination IP, this is going to provide label, and label is going to be popped off here, and again IP enabled IP routing happens here. So it is not correct when someone says when you have MPLS you cannot have security. No, that's wrong. MPLS is nothing to do with security. See, you know that MPLS is added right after layer 2. IPsec is from layer 3 and above. Layer 3 and above. If you want security, you enable IPsec VPN, send the encrypted traffic to ISP, and if ISP has got MPLS, to that encrypted packet's destination IP address label will be given. The encrypted packet carries the label and goes to the other end. And the encrypted packet now goes as an IP packet to the other end of the site, the remote site. So, if anyone asks question, is MPLS VPN? This is the question. Is MPLS VPN secured? No, that's not secured. Can we have IPsec on IPsec with MPLS? Why not? See, sometimes we do MPLS VPN using BGP, L3 VPN. That is not secured VPN. But when you have site to site from here, that site to site VPN is going to go through this MPLS VPN. Now it is secured as well as labeled. Verumane MPLS layer 3 VPN secured ana secured illada. Can I use IPsec along with MPLS layer 3 VPN? Why not? So this answers another question, where to use MPLS. Whenever you want a tunnel, a label switched tunnel, layer 3 VPN, you can go for it. Without VPN also you can have MPLS in the core ISP. With VPN also you can go. Not only that, if you wish to have a layer 2 circuit, layer 2 VPN called VPWS or VPLS, you can go for it. You can go for MPLS. So, MPLS can be used in all the scenarios where IP works. If IP can work, MPLS can work along with that. You should know this one very clearly, where these things are working. IP is working in layer 3. MPLS is in 2.5. Why you need to confuse? It can work. Wherever IP works, I can have MPLS. So it is not correct that saying MPLS is not enabled in service customer side. Why not? You can have MPLS on the customer side. Any question? Come again, MPLS? Yes. If you don't have IPsec between the customer side to customer side, if you don't have IPsec, then MPLS VPN, because of the word VPN, you don't think it is safe. That is what I mean. See, VPN means only encapsulation. IPsec VPN is not VPN. See, I repeat. VPN, if I say, it doesn't mean IPsec VPN. That's what I want to say. Sometimes people think that VPN means secure. No. VPN means encapsulation. VPN means encapsulation. Alright? VPN means encapsulation. So, when you have MPLS layer 3 VPN, you have label encapsulation. Can a label provide security? எப்படி சார் லேபிளே லேயர் 2.5 தான் ஒர்க் ஆகும். அது எப்படி சார் செக்யூரிட்டி கொடுக்க முடியும்? அது லேயர் 3ல ஒர்க் ஆக போதா? இல்லை. லேயர் 4ல ஒர்க் ஆக இல்லை. MPLS VPN is not secured. If you wish to have security, then customer while sending only you encrypt and send. For that only you have IPsec tunnel between this. That tunnel will go inside this tunnel, MPLS tunnel. In that way you can have a secured MPLS. Because of the word VPN, you should not say MPLS is safe. Normal IP internet routing safe illa. IPsec illama is internet safe? Illa. So MPLS is also not safe. It is same like internet only. The only difference is I am not going to route the packet based on destination IP. I am going to switch the packet based on MPLS label. Aste. Beremila. நான் தெலுங்கும் கன்னடம் மலையாளத்தை பற்றி கலந்து பேசுவேன். வேறு ரெண்டுமே தெரியாது வருங்க. சரி, ஐயா, நார்மலாக இன்டர்நெட் நீங்கள் கம்யூனிகேட் பண்ணும் போது அட்டாக் நடக்கும்னா இங்கேயும் நடக்கும். MPLS போடுறதுனால வல்னரபிள் ஆயிடுச்சுன்னு நான் சொல்ல. Because you have enabled MPLS, it became less secured. No. If normal IP packet is under attack, MPLS can also be attacked because there is no encryption. Correct. In IPsec, no one knows what is going inside. Who is talking to whom? So how will you target? But in MPLS you can easily target. Because when you capture a packet, you can see who is sending to whom. Even though labels are there in layer 2.5, in layer 3 there is an IP address to say who is talking to whom. So you can target. Okay. In SD-WAN, this is what people will do. On the edge router, they will connect one internet connection, one MPLS connection, one internet with IPsec, and they will write policy. If my packet is going to that destination, it should go via MPLS. If the packet is going to another destination, it should go with internet with IPsec. If it is going to the other destinations, it should go through normal internet connection. No. One router with 3 connections. One edge router we call a V edge router or WAN edge router. That WAN edge router will have 2 or more connections. One will be internet, another will be MPLS, another will be internet with IPsec. So depending on your policy, for one destination you may need IPsec. For another destination you may need fast, so you will be sent through MPLS. For other destinations you will need normal routing. So those who learn these things proper, for them MPLS is nothing. Sorry, SD-WAN is nothing. But for those who go straight to SD-WAN without knowing all this, is like trying to graduate in a college without having proper schoolings. Okay. Okay then. So we had a good introduction to MPLS. We will we'll do one small lab in our next class. Then I will take you more deeper into MPLS and labels and database, label database, etc., and show you how MPLS makes this forwarding faster than IP routing. Any question?